Hello everyone. We're going to look at radicals, the product rule for radicals, and this helps us to be able to simplify radicals. Another means by doing such. So we have a set of formulas here that we can use and going back and forth. These are the same, okay? This is saying that I take the radical and I break it into two separate radicals. This is saying that I take two radicals and I make them one. I must have the same root index n. So they all have to be like square roots or cube roots or fourth roots. I can't intermingle the different roots. And my radicands A and B must be real numbers. So examples. We're going to multiply and simplify. So here I'm looking at this formula right here. I'm taking two radicals and I'm combining them. So the radical of 3 times the radical 5, or the square root of 3 times the square root of 5, is simply under the radical. This is my new radicand, 3 times 5, which is 15. Square root of 15 is the same value as this. Here I have the square root of 7 times the square root of 7, which I combine those using my product rule for radicals. See? 7 times 7 is 49. The square root of 49 equals 7. Another way to be able to view this is simply this. The square root of 7 squared, which is the same as saying 7 to the 1/2 power squared, which equals 7 to the 2 over 2, which is 1, which equals 7. Okay, so we have 6 other problems under there. If you would like, go ahead and pause the video, please. Work the problems, and let's see if we end up with the same answers. All right. And as I do this, I'm just grouping like terms next to each other to help me visualize. Well, the square root of 4, and I can rewrite it like this, square root of 4 times square root of 3 times the square root of x to the 4th. Square root of 4 is 2. Square root of 3 is simply that. I can't simplify it any more than that. And then this becomes x squared. So 2x squared radical 3. What can I rewrite 45 as? With this, what I'm doing is, and I guess I should have done a better job in explaining this, I took 12, and what I did was, if there's a perfect square that's a factor of 12, for instance, 4 is a perfect square, 2 squared. I try to find that perfect square that is a factor, and that helps me to simplify. So what perfect square, remember our perfect squares, 1, 4, 9, 16, is a factor of 45? Well, 9. 9 times 5. What is the square root of 9? 3. So I pull a 3 out. 3 times 3 is 9. And I'll write that out. 3 times 3 radical 5, because the square root of 9 equals 3. And you can check all of these in your calculator also. It's one of the nice ones that you can be able to figure out. So you can type in 3 radical 15 times radical 3, and then type in 9 radical 5, and you'll get the same values. Okay, what perfect square will go into 54? What is a factor? Well, 9 is a factor. So what I have here I can rewrite it like this. What is the square root of 9? 3. So again, you could type in the square root of 54 and then type in 3 radical 6, or 3 square root of 6. What perfect square will go into 200? The largest one. The largest one. Otherwise, you got to keep doing it. How about 100? 100 is a perfect square because 10 squared is 100. Square root of 100 is 10. Radical 2, I cannot simplify more than that. Again, with your calculator, type in radical 200 and then 10 square root of 2, and you'll get the same value. Alright, square root of 35. What perfect square can go into 35? Nothing. Simply that is simplified. I can rewrite this as radical 5 times radical 7, but that doesn't simplify it any. This is in the simplest form. And my last one, I'll go ahead and just rewrite that as radical 4, or square root of 4 times the square root of 3. 2 times 2, because the square root of 4 is 2, so 2 times 2, and I cannot simplify radical 3. And that's my product rule for radicals. So, you need to remember these formulas right here, making sure that you do understand that you need the same root index to be able to multiply them using the product rule, and that your radicands a and b must be real numbers. They do not, A and B do not have to be the same. If they are, that's nice because you end up with whatever that radical is. Okay, guys, critically think and structure your homework, and in the next video we'll just work some example problems of these.